6.1 Electrolytic cells. Electrochemistry is a study between electrical and chemical phenomena. So in this chapter, we are looking at electrochemistry. In electrochemistry, there are two types of cells, two types of battery. One is called electrolytic cells, one is called chemical cell. Electrolytic cell convert the electric current to chemical reaction. So it converts electrical energy to chemical energy. However, chemical cells, it convert the chemical reaction to electric current. It convert chemical energy to electrical energy. So in this video, we are looking at electrolytic cells, how the electric current can produce chemical reaction, how the electrical energy can produce chemical energy. So in an electrolytic cells, electrolysis happens. Electrolysis is a reaction, it's a decomposition of a compound in a molten or aqueous state into elements when electric current flows through it. So electrolysis is a process, it's a decomposition process. It can decompose, it can break down a compound into its elements. So for example, water, H2O is a compound. It can be decomposed into element, hydrogen and oxygen, when you give it an electric current. But this compound must be in either molten or aqueous state. That means you either melt it or it's a solution. It cannot be solid. So this compound, or we call it this solution, or this electrolyte. Okay, this electrolyte must be molten or aqueous state. So in an electrolytic cells, you have your solution, your compound, and also we call it an electrolyte. So inside this electrolyte, you have positive and negative charged ion. You will definitely have this two charged ion because it's a compound. All the compound, it consists of positive and negative charged ion. Of course, some of the compound that don't have any positive and negative charge. So in that case, we cannot use it as electrolyte. So an electrolyte must contain a positive cation and a negative anion. It also consists of a wire, battery, and you connect to two electrodes, and they are called anode and cathode. Anode is a positive charge electrode, cathode is a negative charge electrode, because this one, anode connect to the positive side of the battery, cathode connect to the negative side of the battery. So they become anode and cathode. So just now we are talking about the ion in the solution. These ions, the positive ions, it will move to the negative electrode. Okay, positive ion moves to negative electrode. So we call it a cation. A positive ion is a cation. And negative ion will move to anode because it will be attracted opposite charge. So this negative ion will be called anion because it moves to anode. Okay, so in an electrolytic cells, we must have a battery or any electrical source. Electrical source produce electric current, and you must have electrode. Electrode must be a conductor so that it can allow electric current to flow to the electrolytes. So these two electrode, anode and cathode, must be a conductor. So when the battery when the wire connect to the battery, the electricity start to flow. The electricity is flow in the form of electron. Okay, so the electron, it will flow in the wire, go to the electrode, it go to the solution, and then it go to another electrode, and then it go to the wire and go back to the battery. So this become a electric circuit. So when the electron is able to move through, the electric current is able to move through this whole setup. The electrolyte, in either in molten or acoustic, it must allow electric current to flow through and undergo. When the electric current flow through them, it will undergo chemical change. This means it will undergo chemical reaction. Now, very, very important, the electrolyte must be in molten state or acoustic. So how do I know that the electrolyte is molten state? So these are some of the examples. You will see the word molten. Molten lead to bromide. This is a compound. It made up of, and this compound is made up of positive and negative charge. Lead is positive, bromide is negative. Molten sodium chloride, sodium is positive, chloride is negative. Some of the example for acoustic, you will see the word solution. Solution. Okay, so sodium hydroxide solution. Sodium positive, hydroxide negative, copper positive, sulfate negative. The word hydrogen means that it mixes with water. So water is H2O. Okay, so inside the H2O, it have positive charge, hydrogen, and negative charge, outside, oxygen. Now, some of the examples that are not electrolyte, that means they cannot conduct electricity. They are compound, but they cannot conduct electricity. So they are not electrolyte. We cannot use it in electrolytic cells. For example, methylene, glucose, and ethanol. There is no charge in this compound. So you learn the basic of electrolytic cell today. Battery provide electric current. So the electron flow through the wires and it go to the cathode and anode. It can also flow through the electrolyte. And then it can go back to the battery. So when the electron flow through this wires, electrode and electrolyte, electric current also flow through it together. Okay, so the electricity will eventually make the electrolyte, the compound here, to be decomposed, to be broken down. So we look at an example. Okay, so this is an example of electrolysis of molten lead to bromide. Okay, so this is molten lead to bromide. Lead is positive, bromide is negative. So you have positive and negative charge in your compound. So very good. This is an electrolyte. It can conduct electricity. You have battery, anode, and cathode. Okay, so the electric current will flow through this whole thing. Okay, so how the electric current can make chemical reaction to happen here in the lead to bromide. Okay, so you see, lead is a positive ion. Okay, lead is a positive ion, bromide is a negative ion. So the lead ion positive will be attracted by the negative cathode. Okay, so a lead ion will move to negative cathode. So lead ion is a cation because it moved to cathode. Bromide ion is a negative ion. It will move to positive anode. So we call bromide ion an anion. So what is a cation? Lead to ion. What is the anion? Bromide ion. So because of the electric current flowing through, because of the electron flowing through the circuit, this lead to bromide is being decomposed in or being broken down into lead ion and bromide ion, and they are separated into two electrodes. Lead will go to negative cathode, bromide will go to positive anode. So they are separated, they are decomposed. This is a chemical reaction. However, electrolyte in solid state cannot conduct electricity. Okay, it cannot conduct electricity because there is no free moving ions. Lead to bromide solid, it cannot conduct electricity because the ion, the lead ion and bromide ion, they are in a solid state, so they cannot move. So because they cannot move, they cannot be attracted and they cannot move to anode and cathode, so there is no reaction. So very important when the question asks why solid state cannot conduct electricity, why in solid state there is no reaction, because there is no free moving ion. Okay, so what happens when this lead and bromide move to cathode and anode? Okay, so after the lead ion move to cathode and bromide ion move to anode, they are separated. Okay, and what happened next? Okay, so this is what happened. At the cathode, the lead ion will discharge to become lead. It's an atom. Okay, so it's a solid. So you will see lead stick to the cathode. And then bromide ion is a non-metals. Okay, so it will also discharge and form bromine. It cannot form ion, it can only form molecule. So Br2, and it's a gas, bromine gas. So all the elements that will exist naturally either in atom or molecule. So for lead, it will form an atom, and for bromine, it will form a molecule. So it's a bromine gas. So how do you know that if I change it to other compound, how do you know that what it will form? So very simple. It's a metals. For example, lead is a metals. It will definitely form atom. It's a solid. If it's a non-metals, for example, bromine. Bromine is not a metals. It will form molecule and it will be gas. Okay, so let me explain why. Okay, why the lead ion 2 plus, the charge is gone, it become Pb only, and why bromide, the negative charge is gone and it become bromine gas. Okay. Okay, so first we look at lead ion, lead 2 ion. Okay, what is 2 plus? What this 2 plus mean? This means this lead previously, let's say, okay, so let's say this is the lead, and on the last shell, it have 2 extra electrons. So this lead lose this extra 2 electrons. The lead don't want these 2 electrons. So because he donate the electron, throw away and donate the electron, so it's left with only 1 shell. Okay, so the last shell is gone because it throw away the electron. So now because it throw away a negative electron, it throw away 2, yeah? It throw away 2 negative electrons, so now it become a positive charge. Okay, because remember in an atoms, inside the lead, okay, inside the lead you have proton and electron. This proton is a positive charge. So before that, the number of proton and number of electron is the same. So let's say here I have 10 electrons. So inside also I have 10 proton. Electron also I have 10 electron. So this one means no charge. Okay, of course lead is not 10, the proton number is not 10, the electron is also not 10. This is just for example for you to understand. So when the proton number and the electron are the same, because electron is negative, you have 12 negative electron and you have 12 positive proton. So plus and minus is neutral, no charge. But because of these two extra electron on the last shells, it feels very lonely, okay? And it's very not stable. So this lead will donate, it will throw away these two electron. So as it throw away these two electron, it become 10 negative electron and 12 positive proton. So what happens is it have more positive proton. It have 2 more positive proton. So it will make it a 2 positive charge. This one is for lead. Okay, so now back to the question just now. Lead now is ion. Okay, so it will be it turn back to atom. Okay, that means it turn back to atom by accepting 2 electrons. So now these 2 electrons come back. Okay, when these 2 electrons come back, it go back to this state. 12 negative electron, 12 positive proton. Okay, so it become atom again, no more charge, neutral. Okay, so where these 2 electrons come from? These 2 electrons come from the battery. Okay, remember when the electric current start to flow, the electron flow to the cathode and also flow to the anode. So this electron comes from the battery. Okay, so look at here, cathode. Okay, here. You see, the electron flow like that. Okay, the electron will flow from the negative side of the battery. It go to cathode, and then when it go to cathode, the lead 2 plus, okay, the lead 2 ion get these 2 electrons and come back to atom. Okay, now we look at bromide. Okay, bromide, it will also lose the negative charge. So bromide is opposite. Bromide is a negative charge because it receive 1 electron. So this is let's say this is a neutral, no charge bromide. 1, 2, 3, 4, 5, 6, 7. It has 7 electron and proton also 7. Okay, 7 proton. So neutral, no charge, but it will get another electron. So it will get an extra electron from elsewhere. Okay, so now it becomes 8 electron, but 7 proton. So it get 1 extra electron, so it's a negative charge now. Okay, so now if bromide want to go back to neutral, it need to throw away this electron. It throw away back, right? So it will minus 1 electron. So minus 1 electron. Okay, so it become at the neutral. And then this one, it will combine with another bromide definitely and become molecule, because bromide atom that cannot, they are very reactive, they cannot be alone. They will combine with other bromide atom and form bromine gas. So this is what happened. Okay, So now this electron is being minus away, is being thrown away by the bromide ion. So where this electron go? So you look back to here, okay, bromide. So this electron will go to the anode. Okay, this electron will go to the anode here and go to the wire. So electron, this electron, it will go to the cathode, and then at the cathode, the lead positive charge, it will accept this electron and become lead. And what happened here at the anode is the bromide negative charge. It will throw away this negative charge. One electron. It don't want this electron, and it will become a bromine gas. So this electron will go to this cathode and flow back to the wire. Okay, so this is the movement of the electron. So when electron move in the cable, the electron move in the solution, the electric current also flow. So the flowing of the electric current and the flowing of the electron that occur at the same time. And during that times, all this happens. Okay, all this that happen together. Okay. So this is all of the story.